All right, part 3. I looked through it, and it turns out that through all of my mess right here, this was supposed to be a minus sign. I knew something was awry because all these were positive. I would not have gotten 0 at the end. So once this is negative, then the negative 5 plus 3 would be negative 2. So that should have been negative 2 instead. That would still be a 1. So then we'll continue. 3 times negative 2 is negative 6. And if you add, you get negative 2, multiply negative 6, add negative 3, multiply to negative 9, and you get 0, of course. Okay. That was our 3, and it works. Cha-ching. Next up, since its multiplicity was 2, that means you could actually do this thing again with the number 3. That's what the multiplicity of 2 means. It means it works twice. Why would we do this? I'll tell you later. So drop down the 1 again, multiply, and add. And I'll remind you, if I'm going too fast, once again, you have a pause button, so use it. 3 times 1 is 3. Add. Negative 2 plus 3 is 1. Times 3 is 3, and you get 0. Boom, like that. Okay. You need to keep doing synthetic division with all the numbers you have until you have 3 numbers. That's important. The reason you have to have 3 numbers is because we are now going to use the quadratic formula with those numbers, where this is A, this is B, and this is C. Behind the scenes kind of thing is that this is technically a 1x squared plus 1x plus 1. That's what these correlate to. So this is a 1, a 1x, and a 1x squared. But in the quadratic formula, you use the numbers in front. And since these are literally the numbers in front, you don't really need to show this step. You just have to know that this is A, B, and C for the quadratic formula. Speaking of, is negative b plus or minus the things I'm going to write down. There we go. And you're going to plug this in. So b was 1, so we'll have negative 1 plus or minus. 1 squared is 1, minus 4 times A times C over 2 times 1. So I'm plugging into the formula. Once again, feel free to pause if you need to kind of think about why I'm doing all that stuff. So we get negative 1 plus or minus the square root. This is just going to be, 4 times 1 times 1 is 4. So 1 minus 4 is negative 3 over 2. You can't square root a negative, so the most you can do is put an I in front. And that right there would be the other 2 solutions. They're imaginary. They don't actually exist. That's why on the graph there's no other zeros there. These are the quote-unquote hypothetical solutions. So I'm just going to go over here and write them down. Negative 1 plus or minus I root 3 over 2. Since these are not actual zeros, there is no multiplicity, so you don't need to talk about it. And that's it. Okay. Next problem. First thing I'll do, well, maybe the first thing I'll do is double check that I have all these. These are all positive and the last one's negative, so if I accidentally write over it, I'll remember positive, negative. Okay. So, positive, 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 negative. So does not change, does not change, does change. So there's one change. This is an odd exponent, so it changes. This is even, so it doesn't change. This is odd, so it does change. And this is even, so it doesn't change. So you are changing the odd exponents, and now you recount. This is a change, this is a change, this does not. So there are 2 total changes afterwards. Possible roots. See if you can remember what possible roots are. Feel free to pause, think for 20 seconds, and then unpause it. Do you remember how to do possible roots? The answer is P over Q. 10 over 1. The things that go into 10 are 1, 2, 5, 10. Things that go into 1 are 1. So you end up with plus or minus 1, 2, 5, 10. So if I graph it, it should go through one or more of those. Otherwise, Mr. Anderson did a boo-boo when he was making the problem for you. Hey, hey, look at that. We have 3 nice, perfect little answers. 1, 2, 3, 4, 5, so -5, -2, and 1. And sure enough, all 3 of those were possibilities we wrote down. So -5, 1, 2, 3, 4, 5, 2, 1. Wrote them there. It looks like there's a relative max and a relative min. End behavior, it looks like this one goes down and this side goes up. Relative max and mins. Let's do max first. Boop. 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 Relative max is -3.7, comma 10.4. So 1, 2, 3.7-ish, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know, it's going to be up there quite off the graph. And the relative minimum. -0.3, comma, -10.4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-ish, right there, whatever. Either way, it's going down there, it goes up to up, down to down, and up like that. So it looks something like that. And there you go, that's that entire problem. That's the first page done. Then there's one more page, which has 3 more questions on this side and then a bunch on those. So we'll see how much we got done. This is a new type of problem. These are not in standard form anymore, they're in factored form. So this is done a lot differently. First of all, you can find the zeros without graphing it. You could graph it and find them. Hopefully you don't have to, because it is something that is important for more than one unit we're doing this here. You should be able to look at this and say that -3 has a multiplicity of 2. The multiplicities are given to you in the exponent. This would be a 0, 1, a 0 of 1, and its multiplicity would be 1. Meaning, it's going to go through -3, it's going to go through 1, and it's going to bounce off the -3 because it has a multiplicity of 2. You can also tell that since it's negative, that it's going to end going down. So I know for a fact it's going to look something like that, because it has to end going down and it's going to go straight through 1. And then it's going to go up some amount, and then it's going to come down here and it's going to like bounce that way. Once again, I don't know what the max is going to be, but it's definitely going to bounce off of -3 and go back up some amount like that. So I could do that without looking at a calculator. You could if you wanted to as well, but I'll just type it in. Negative x plus 3 to the second x minus 1. If you ever get error, just like an error message, because that happens to some people. If you ever get error when you're trying to graph things, just double check you're using negatives instead of minuses and things like that. That's the most common thing. That's a minus sign, well, that's a negative sign. And as you can see, it looks like right here is going to be the maximum. And you can see that what I've filled in already is correct because I said it, and therefore it has to be correct, right? Let's find that relative max then. Doop-a-doop. And it looks like it's negative 1/3, negative 0.3 repeating. So negative 1/3, then 9.5-ish. So 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. And there we go. It's beautiful, isn't it? So this side is going up to positive infinity. This side is going down to negative infinity. And this relative min, you know, I can tell it's negative 3, 0. If you're just in that zone, you just got to use your calculator. Then you could do this. And sure enough, negative 3 with a bunch of zeros. Once again, this just means it's negative 3. So negative 3, comma. And then you get this weird thing right there. It says 7.4, and then some people start writing 7.4. Just keep in mind this little e here. If you ever see this, it just means it's 0. It's scientific notation saying that this number is put to the times 10 to the negative 12th power, which means it's basically 0. And in calculator speech, it is 0. Just make sure that what you're looking at makes sense here, because if you actually plotted negative 3, 7, that doesn't make any sense. You can see that it's negative 3, 0. So write negative 3, 0. Okay. That's it for number 4. Still have 5, 6 in the bath to go, but we'll do that in another video. Thanks for watching, if you did.